So let's do this. Oh, come on. Unit 3. Quiz, we did 80%. Okay, more. Comparing means of distributions. Means and medians of. Okay. Not started, not started. What do you mean? I got 2 not started. Let's start this one. Find the mean of the data in the paragraph in the pictograph below. So I got equal 1. So I got here 1, 2, 3, 4, 5. 1, 2, 3, 3, and 5 also. So I got the mean 16 over 4. That's 5 plus 5 plus 3 plus 3. That's 16. 16 over 4. That's 4. Update available. Please update. 4. Do update. Find the mean of the data in the dot plot. Okay, I got 0. I got 1, 2, 3, 4, 5. I got 5 over 4. It's 5 over 4. 5 over 4. 1.25. 95. It's a 5 over 4. 1, 2, 3, 4, 5. And how many data sets do I have? 1, 2, 3, 4, 4, 4, 4. What do you mean? So over 4. 5 over 4. 1.25. Are you for real? Is he asking for median or mean? Mean. Mean. I got 1, and I got 1, and I got 2, and I got 1, so that's 5. And I got 4. How many? 3 jokers. Number of jokers. 3. Do I have 3? So it's 5 over 3. Are you saying 5 over 3? 1.67. Is that what you said? Yeah. Number of jokers. You got 0 jokers, 1 joker, 2 jokers, 3 jokers. So, and I got jokers in each of Marcy's decks of cards. She got decks of cards. She got 0, she got 1, 0 jokers, and 1 joker, and she got 2 jokers, and she got 1 3 jokers. If we are to distribute them over this You're gonna get 5 over 4. You're gonna get 5 over 4. So first let me update the ulama. And ulama, what's happening? You said there is an update. Update. You're up to date. Not system. Apps. God damn it, why isn't it updating? Update for fuck's sake. Okay. Hint. Give me a hint. The mean is 1.6 jokers. She got 0 plus 1 plus 2. Oh my god. Plus 2 plus 1. Yeah. Plus 2 plus 2 plus 3. 8 jokers. 8 over 5. Okay. Find the mean of the data in the bar chart below. Persons, piggy bank, dollars. Okay. Money in each person piggy bank. Sheen has got $18. Okay, find the mean of the data in the bar chart below. So go 18 plus 4, that's 22. Okay, 18 plus 4 plus 12 plus 8 over 4, 10 and a half. $10 and a half. Okay, find the mean of the data. Number of fishes. Fish Ima caught each day of her fishing trip. So she got 0, 0 plus 3 plus 6 over, I don't know, 6 days. She had 7. Wait. Caught each day of her fishing trip. Over 3. Because she had one day she got 0, one day she got 3, and one day she got 6. So it's over 3. That's 3. Let's go 3. Okay. Okay. Size of each of Mr. Xerox classes. Number of students. So she got 4 classes. 4 classes. Huh? So she got 20 plus 23 plus 25 plus 28 over 4. That would be 24 students. 24 students. Okay. Next, following frequency table shows the number of bags each exchange student from Bridgewater University packed. Number of exchange students. Find the median number. So the median number of bags. So I got 1, 2, 3, and I got 5. I got, it's gonna require really and truly, what do I have? So what do I have? Okay. I got 1 bag. I got 2 2s. I got 1 3. I got 0 4, which is not, and I got 5. Am I correct? X backed. So I got 1 2 3 4 5. 1 2 3 2. The median is 2. It's 2. Okay. The median distance. So I got 3 kilometers. I got 4, 4. I got 5, 5, 5, 5. And I got 7, 7. 1 2 3 4 5 6 7 8 9. So number 5. 1 2 3 4 5. 5. So the median, the ages are 1 2 3 5. Of cousins, choose. There are 5 ages, so the middle age is the third value. 3. The median age is 3 years old. What mistake did Marta make? There is no 2. So Marta calculated the mean instead of the median. Marta should have ordered the numbers from least to the greatest before. They should have averaged the middle 2 values instead of using just one. Or they should have repeated some of the values in their list. She does. She choose one answer. Repeated some of the values in their list. I would go with that. Did she calculate the mean? Okay. Following frequency. Trees each person planted at a volunteer event. Okay, number of people. Find the median number of trees planted. This is the trees planted. So I got 2, 3, 3, 3. I got 4, 4. I got 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Got 8. So 1, 2, 3, 4, 5. These two. And I got that's plus 7 over 2. That's 3.5. 3.5 trees. Okay. Comparing means of distribution. I got 4 videos. Next. 4 videos.
Kenny interviewed freshmen and seniors at his high school, asking them how many pieces of fruit they eat each day. The results are shown in the 2 plots below. And so the first statement that we have to complete is the mean number of fruits is greater for, and let me go to the actual screen, is greater for, and we have to pick between freshmen and seniors. And then they say the mean is a good measure for the center of distribution of, and we pick either freshmen or seniors. So let me go back to my scratch pad here, and let's think about this. So let's first think about the first part. So let's just calculate the mean for each of these distributions. And I encourage you to pause the video and try to calculate it out on your own. So let's first think about the mean number of fruit for freshmen. So essentially, we're just going to take each of these data points, add them all together, and then divide by the number of data points that we have. So we have one data point at 0. So we have one data point at 0. So I'll write 0. And then we have 2 data points at 1. So in a color that you can actually, let's see, 55. So this is equal to 55 over 16, which is the same thing as, let's see, that's the same thing as 3. And 3 times 16 is 48. So 3 and 7 sixteenths. So the mean for the seniors, 3 and of pieces of fruit. If you change this 1 point all the way out here, it's not going to change what the middle number is. So the mean is more sensitive to these outliers, to these really about the bulk of this distribution right over here. 4 really doesn't look like the center of it. The center of it looks close, skewed the mean upwards. While here, that 3 and 7 sixteenths really did look
seniors, yes. Because there's an outlier. Understood.
For a senior project, Richard is researching how much money a college graduate can expect to earn based on his or her major. He finds the following interesting facts. Basketball superstar Michael Jordan was a geology major at the University of North Carolina. There were only 3 civil engineering majors from the University of Montana. They all took the exact same job at the same company, earning the same salary. Of the 35 finance majors, and visualize this a little, tell us about US 50K plot of. So when you have Montana, the median income will be blank the mean. Well, they tell us there were only 3 civil engineering the mean. $1 a year?
Okay. So you're going to have to.
Anna played 5 rounds of golf, and her low score was an 80. The scores of the first 4 rounds and the lowest round are shown in the following dot plot. And we see it right over here. The lowest round, she scores an 80. She also scores a 90 once, a 92 once, a little bit.
Mean, we can calculate the median and mean.
It will increase, but the mean will increase by more than the median. That's exactly what happened. The mean went from 90 and 2/5, or 90.4, went from 90.4, or 90 and 2/5, to 93, and then the median only increased by 1. So this is the right answer. Let's think about what happens to the median. How will this is the lowest score of the friends after Adam Bolsh and his that's going halfway between to be higher because their sum is going to be larger. And so the mean is going to go up. The mean will increase. But maybe the C for this example.
We're going to have to. Oh no, I feel this is...
These 4 and divide by 4, you're going to have a larger value than if you take these 4 and divide by 4 because their sum is going to be larger.
So let's do some exercises. At track practice, Sierra ran 5 attempts of the 100-meter dash. All of her times were different values between 11 and 13 seconds, except for an attempt when she tripped and finished in 24 seconds. Alexa's coach said they would remove the 24th result from the set of these practice times. How will removing this time affect the mean and median? Well, the mean is gonna reduce. Am I correct? Let's check it ourselves. She got 5 attempts. Her attempts, her fill times were values between 11 and 13 seconds. So she got 11 and 13. So 12. I don't know. All except for an attempt when she tripped and finished in the 24th. So this is not needed. All what we have to do is 1 at the 24th. Okay, so the mean is 124 plus 13 plus 12 plus 11 plus 11 over 5. So I got 24 plus 13 plus 12 plus 11 plus 11. That's over 5. That's 14.2. So removing the 24th, what do we get is the mean. The mean. Remove this time effect. Alexa, remove the 24th from the set of these practice times. Okay, so she got 24, not 24, 13 plus 12 plus 11 plus 11 plus 11 over 4, 11.75. Either ways, it's going to reduce. The mean is going down. Even if we said, even if we go back and 5, that's 2.32. So even if we kept it over 5, so 13 plus 12 plus 11 plus 11 over 5 is going to be 9.4. Either ways, it's going to go down. So how about the median? The median, okay, the median. So the mean is going to go down. Median is equal, I got 11, 12, 13, 24. 1, 2, 3, 4, 5. So the median here is 12, Let's remove the 24th. What are we left with? The median is 11. So I got 11 and 12. 11 plus 12 over 2. 11 plus 12 over 2. 11.5. So I got 11.5. So both the median and the mean will go down. But the median shouldn't be, if this time was 12, the median wouldn't have any, you know what I mean? So it doesn't say anything. It says different values between 11 and 13 seconds. Different values, meaning the mean is definitely going to reduce. Different values meaning between 11 and 13, meaning they were not, okay, new page here. Different values meaning 11, 11 and a half, 12, and 13. Am I correct? And 13. And 24. Because it has to be different values. No value is the same. So the mean is gonna go down either ways because, let's face it, 11 plus 11 and a half plus 12, 12 plus 13, 24 over 5, that's 14 plus 3. Ah, come on. Oh, come on. Stop. Mean. Okay. Next round is, let's say, 11 plus 11 and a half plus 12 plus 13 over 4. That's 11.870. Down. Median, I got the median here is 12. Median is 12. 12. And then I got median equal 12 plus 11 and a half over 2. That's 17. Wait. 12 plus 11 and a half over 2. That's 11.75. So either both went down. So the outliers affects both. Yeah? Mean will decrease, but the mean will decrease by more than the median. I guess this one. Am I correct? Yeah. Okay. Anya played one round of her favorite online game every day, 1 week. She played 7 rounds and scored between 120 and 13 points, 300 points each round. She calculated the mean. Then Anya found out the point was a special double points day, so she actually earned 600, not 300. How will this amount increase affect the mean and the median? Wait. Anya plays one round of her favorite online game every day. One week she played 7 rounds and scored between 120 and 300. Now, I guess they will increase, but the mean will increase. Both the mean and the median will increase. Not the same. The mean will increase well. The median will decrease. Ah, the mean will increase and the median will stay the same. Yep, the median will stay the same. The mean will increase. The median will stay the same because the 600 became the 300 was special double day, so she actually earned 600 points. So the median will stay the same while the mean will increase. Okay. Brandon works at a petting zoo with 8 animals. We are looking at some data showing the mass of the animals. Each animal had a different mass between 2 and 160k. The zoo then buys a horse that weighs 900 as their ninth animal. How does buying the horse affect the mean and the median? So each animal had a different mass between 2 and 60 kilograms. They will both increase, but the median will increase by more than the mean. I don't think so. But the mean will increase by more than the median. Yep, Ariana was looking at recent costs for 5 apartments. At a rent cost for 5. Each rent was a different amount between 1,000 and 1,400 per month, except for one apartment whose rent was 4,800 per month. The mean and the median of the rents. Then she decided to remove from the set and recalculate the mean and the median. Well, they both will decrease. Both the mean and the median will decrease, but the median will decrease by more. No, but the mean will decrease by more than the median. Yep. Yep. Okay. Mean as the balancing. No. Unit 3, where are we? Okay, quiz 1. Okay. Mean as the balancing point. Find the mean. Okay. 5 plus 7 over 2 is 6. Find the mean of 5, 6, 7. Well, it's gonna be, guess, 6. 5 plus 6 plus 7 over 3. It's 6 here. Oh, check. Okay. Check. Find the mean. 135. So the mean is 3. Because we're adding 2. 2 and 2, the mean is 3. 3 I would go. The mean is 3. So we can 9 over 3 is 3. Okay. Find the mean of 4, 7, 10. That's 4. Okay. Find 4, 7, 10. I don't know. 7. 4 plus 7 plus 10 over 3. It's 7. Okay. So the mean is not really 2, 3, 5, 6. So we got 5, 10, 16 over 4. That's 4. 4. Okay. You might have noticed about that. Find the mean without finding the total order. Key idea, we can think of the mean as the balancing point, which is a fancy way of saying total distance from the mean to the data points. The mean is equal to the total distance from the mean to the data points above the mean. Example, part 1 you found the mean. Yep. What is the total distance below the mean in this example? What? From the mean to the data points below the mean is equal to the total distance the mean to the data points above the mean. So the mean is equal to the distance from the mean to the data points above the mean. Okay, so above the mean is 6, from 4 to 6. Below the mean is 3 and 2. Total distance below the mean. Total distance is 2. 2. Oh really? What do you mean? This is the mean. It's the total distance below the mean. Example. Some question. It's example. And this 2, 3, 5, 6. So, and the mean is 4. We found the mean to be 4. So what's below it? 3 and 2. Is it 5? 3 and 2. 3 is the total distance above the mean. 5 the mean is 4. Got 5. 3. 6. Got 6. Got 6. 3. 6. Also 3. because it's balanced. So we got 3 and we got 3. Four, 5, 6. That's 3. Right. It's 2. That's 1, 2. How's it 3? I have no idea. So, I have no idea. I didn't get this. Starts with 2. 2 to 3, that's 1. To 4, that's 1. Plus 2. Okay, that makes sense. That makes sense. That makes sense. Okay. Is the mean always the balancing point? Which of the lines represents the mean of the data point shown below? So 1, 2, 3, 4, 5, 6. 6. The mean is 3. 1, 2, 3. C. So from here to here 1. From here to here 2. And from here to here 2, 3. Got 3. So 1, 2, 1, 2, 3. C. 1, 2, 2, 3, 4, 5, 5, 5, 6, 6. So we got over 3. 1, 2, 3. Let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 6. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 5. Which is the balancing point? 1, 2, 3. It's 3 here. It's either this or this. It's either B or C. So 1, 2, 1 and 2, 1, 2, 3, 1, 2, 3, 1 and 2. So it's C. It's C. Yep. Problem 2. Which of the mean of the data points shown below? That must be B. Yeah. 1. Wait. Must be C. I got 1, 2, and 1, 2, 3. That's how much. That's how much. 1, 2, 3. That's 6. 1, 2, 3. 1, 2, 1, 2, 3. 1. It's 9. So it's B. 1, 2, 2, 2. That's 6. 1, 2, 3. So it's B. It's B. Fucking B. Choose the fourth data point. The mean of 4 data points is 5. 3 of the 4 data points and the mean are shown in the diagram below. Wait, what? 3 of the 4 data points. It's definitely gonna be here. Here. 3. It's definitely because 1 and 2. 1 and 2. That's 3. Nope. 1. Wait. 2 and 2. That's 4. No, this gotta be 4. So this is 1. The rest is 3. 1, 2, 2. Well, this is hard to not only to grasp but to remember these things. Okay. Missing value, some value giving the mean. Missing value giving.
Let's say you're in the babysitting business and you like to keep a log of whom your log, you know that every so given that so let's just think number of ages, the number of
This is easy. This is math. So you got to add them all. This is pure math. You got 5 plus 2 plus x plus 2 plus 4 plus 8 equal 4. We're gonna, okay, so how's this gonna be? Over 1, 2, 3, 4, 5, 6, 6 over 6. So we're gonna, first, what are we gonna do? So let me add them. It's gonna be 5 plus 2, 5 plus 2 plus 2 plus 4 plus 8. So it's gonna be 21 plus x over 6 equal 4. We're gonna multiply both sides by 6. 6 goes with 6. So 4 multiplied by 6, that's 24. So we got 21 plus x equal 24. We're gonna move this to the other side, so it's gonna be x equal 24 minus 21. Changing the sign, it's gonna give me x equal 3. So this, do we need
on that side, and then left with the data points 4. Let me do 21. We just wrote it all denominator, those can't. So we get 20 plus 4, 3, or if is equal to out that behind. It's exciting.
they get the same? 3, huh? Yep. Missing value giving the mean and range puzzlers. Okay, ready to practice. Mean, huh? The mean. I don't think you can get the median though. But I got 1 plus 4 plus 3 plus x. If the mean of the data set is 3 puppets equal 3, this is over 4. Multiplied by 4, this goes. What are we left with? 3. So I got 1 plus 4, that's 8, plus x equal 12. So I got x equal 12 minus 8, which is equal 4. Equal 4, am I correct? Let's check that out. 4. Check. Okay. 103. I got, doesn't matter, 1 plus 0 plus 3 plus x over 4 equal 2, multiplied by 4, this goes. I got 13, wait, 13, 4, sorry, not 13. I got 4 plus x equal 8. So x equal 4. 4. Yep. What are we having? 11 plus 12 plus 7 plus 3 plus x equal 8. 1, 2, 3, 4, 5. 5 over 5. So we're gonna multiply this by 5, so this goes. And we got 11 plus 12 plus 7 plus 3, that's 33, plus x equal 8 multiplied by 5, that's 40, x equal 7. Because 40 minus 33 is 7. 7. Okay, now give me a new one. I got, okay, so let me see. I got 4, that's 10, plus x is over 5 equal 3. So I got x equal 5. Because this is going to be 15. Okay, I'm going to go with 5. So should we finish this set, the last one? Puzzlers.
Let's say that we run a car dealership and we have 11 salespeople. And we record the number of cars each of the 11 salespeople sold in the past week. So this is cars. Maybe the next car sold them all from actual numbers. I just made those up. But we know that the middle number needs to be 6. So let me just find ourselves the number here because we've solved the minimum. And they're telling us that that is 4. This range is 4. So the maximum minus the minimum. The difference between the number of cars that the least productive salesperson sold, that difference is going to be 4. So given all of those assumptions, giving all of that information, I'm now going to give you a statement. And
wait, median has 6 cars, range cars 4. What does the range mean? 11 salespeople. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does the range mean? 4 cars.
And our challenge is, if we assume everything I just said is true, is this statement going to be true? Or is this statement going to be false? Or do we not know? So middle number. So the middle number, if you have 11 data, is 6. Old 10 cars, 10, 11. Each of the 11 sales. So we record 10 cars. So if we ordered all of these, them sold. So maybe one person sold, maybe they sold 5 cars. Maybe the next person sold 7 cars. Maybe the next person sold 10 cars. And so that's how we would do it. So we're going to record all of that. But then we're told that the median car sold, and I'm just, middle number here is going to be 6. Now we don't know whether all of these other numbers are the actual numbers. I just made those up. But we know that the middle number on either side. So that's that one. We know the median. Actually, let me do that purple color. The median is going to be median. We know the median. Actually, let me do that. Now the other thing we know is that the range of cars sold is 4. And let's remind ourselves, the range is the maximum number of cars sold minus the minimum number of cars sold. And if we have sorted all of these out, this, if we take a range, is going to be our max minus.
And this is the median, not the mean. We got 6. So there's no way.
Minus our min. So let me write that down. So you take your min and your max, you have your range. Range is equal to the maximum minus the minimum. And they're telling us that that is 4. This range is 4. So the maximum minus the minimum. The difference between the number of cars at the. So given all of those assumptions, giving all of that information, I'm now going to give you a statement. And our challenge is, if we assume everything I just said is true, is this statement going to be true? Or is this statement going to be false? Or do we not know? So let me write this down. So is this going to be true, false, false, or do we not know? Do we not have enough information to say it's for sure going to be true, for sure going to be false, or for sure we don't know? And so I encourage you to pause the video now and try it out. All right, so let's work through it together. This is kind of a fun puzzle here where we've been given some clues and then we have a statement and we figure, can we make the statement? Can we say it's true, or can we say for sure that it's false, or do we just not know? So a couple of ways to...
Well, actually, max minus min is equal to 4, but we have a median of 6, so we have at least one sold 6 numbers, 6 cars.
To tackle it. One way to tackle it is, well, look, one of the salespeople must have sold 6 cars. If the median sold is 6 and there's 11 salespeople here, the middle number here, that if we order it, one of them must have sold 6 cars.
Okay, the max could be 6 and the min could be 2. So
if we had an even number here, then that would be the average of the two middles. But if we have an odd number here, that is literally the middle number of cars that somebody, the middle number of cars sold. So someone sold 6 cars. So if we assume, and we're trying to find a world where someone sold more than 10 cars. So if someone sold 6 cars, is there a way with a range of 4 that someone sold more than 10? Well, let's just think about it. Let's just assume that the min is 6. We don't know that the min is 6, but let's just try it out. If the minimum is 6, what's the maximum going to be? Well, remember, the range is equal to, we know that the range is 4. The range is equal to the maximum minus the minimum. Maximum minus the minimum. And so the maximum in this case would be 10. Max would be equal to 10. If the min is equal to 6, and I said of course,
but it could be 6 also.
if the min is equal to 6, then the max at most can be equal to 10. And we can't take a higher min because we know that the 6 is going to be one of the values. We could try a lower minimum value. We could say the minimum value is 5 or 4 or 3 or 2 or 1, but then the maximum would go down even more because remember, the maximum is no more than 4 larger than the minimum. So if we assume 6 and we know that one of the salespeople sold 6 cars, then the maximum that any of the salespeople could have sold is 10. And so the statement, at least one of the salespeople sold more than 10 cars, that's gotta be false. That's gotta be false. Now there's another way that you could think about it. You could assume that someone sold more than 10. You could assume, in the last example, or the last way of then the max at most can be equal to 10. And we can't take a higher min because we know that the 6 is going to be one of the values. We could try a lower minimum value. We could say the minimum value is 5 or 4 or 3 or 2 or 1, but then the maximum would go down even more because remember, the maximum is no more than 4 larger than the minimum. So if we assume 6 and we know that one of the salespeople sold 6 cars, then the maximum that any of the salespeople could have sold is 10. And so the statement, at least one of the salespeople sold more than 10 cars, that's gotta be false. That's gotta be false. Now there's another way that you could think about it. You could assume that someone sold more than 10. You could assume, in the last example, or the last way of thinking about it, we assumed that the min was 6. But now let's just assume that someone sold, let's just try cars. If the max is equal to 11, what's the min going to need to be? Well, we just have to remind ourselves, range is equal to max minus min. So 4 is equal to the maximum, 11, minus the minimum. So 11 minus what is equal to 4? Well, 11 minus 7 is equal to 4. So if we assume that the maximum is 11, then the minimum is going to have to be equal to 7. Now, can the minimum be 7? And it means if are going to be true. Can't be true. So once again, yes.
Okay, got it. Let's do the last one, the last bit of today's statistics and probability. The median number of baskets made by 7 players in a certain basket. 5. The range, the number of baskets made by the 4. Determining if the fewest baskets made is 4, then the greatest number of baskets made is 9. Okay. The median is 7. I got 7. And in a certain basketball game, median number of baskets made by 7 players in certain is 5. 5 is the median. The range is 4. So I got So I got 5 is the median. Okay? The only lowest, and that's the middle. So if we take it to be the range, that game is 4. The range is 4. Okay? So it can be the fewest is 4 and the greatest number. So 9 minus 4 is 5. False. This is false because the range is 4 and the range here is 5. Am I correct? False. Okay. The greatest number of pools installed could be 20 pools. The median number of pools installed is 9. I got 9. Certain summer of pools installed by 9 construction team. Certain is 11. I got 11. The range of the number is 14. I got 14. So the greatest number of pools installed could be 20. So if we said that 11 is the lowest, 20 minus 11, that's 9, which is not 14. But it can be lower, which is 20 minus 6, so it's 14. So could be, yes, it could be the number of pools. Seems that 7 is 14. It could be is 11. The median is 11. It could be 20 pools. Who knows? Yep. Determine if the greatest number of pools installed is 18, then the fewest pools installed is 6. I got median number inserted 11. I got 11 median, and I got range of 14. So 18 minus 6 is 12. Am I correct? Yes, 12, and that's not 14. False. Okay, at least one of the sales representatives sold more than 10 cars. I got the median number of cars sold by 11 sales. 6. I got 6. The range number of cars 4. So I got 6 as the lowest. I got 10 minus 6 is 4. at least salt more than 11. More than 11 meaning that, no, false. This is false. We took it in the example, but this is false because 11 minus 7 would be 4, and 7 is not the median, meaning in no way there is 6 lower than 7. So this is false. Okay. Quiz 2. Should we take quiz 2 today? Should we? Should we not? Should we? Should we not? Seriously, guys. Oh my god. Oh my god. Should we? Should we not? Okay. 5 questions. Determine at least one of the model made more than 9 magazine appearances. What it says. The median number of magazine appearances was 7. By 7 models is 5. 5. The median is 5. The range of number of magazines appearances models is 5. Range is 5. One of the models made more than 9 magazines. 10, let's say. 10 minus 5 is 5. Is 5 at least one. Not enough information, I would say. At least one of them. Not enough information. Not enough information. I can't say. Okay. Find the mean of the data in the dot plot below. I got mean 4, that's 8, plus 7. 8 plus 7 over 3, that's 5. 5. What is that? The mean, 5. I got another wave. This is 2. It's 1, 2, yeah. It's 5. Okay. Lara is a wildlife researcher, analyzing the mean and median lengths of 7 fish. Their team had observed. The fish all had different lengths between 15 and 33 centimeters. Found out that they were misreading the longest length. It was actually 88, not 33. The length increase affect the mean. Okay, will increase, that's true. Wait, the median will stay the same because she misread it, meaning that 33 is gone. Yep, the mean will increase and the median will stay the same because that's only what she does. They were misreading the longest length. Was actually, yeah. Okay. Following data want to represent the number by each player. 5, 8, 11, 7. So I got first 8 multiplied by 5 minus 5 plus 8 plus 11 plus 7. It's 4. 9. I got 9. Okay. The following show height of each toddler at Miss Cambridge daycare. Find the median height. So you got 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. So I got 8. The median is number 4, which is here, and number 5, which is here, over 2. So I got 83. Am I correct? This is 6, 8. So I got it divided by 2. That's 4. And I got 4, number 4, number 8, because let's face it here. This and this. So we'll leave 3. And this will leave 3. So I got this and this. I got 138 and 140, 84. 183 plus 184 over 2. That's 83.5. 83.5. And that's the median, baby. Okay, that's it for today's statistics and probability. See you later, you guys.